small step for man, one giant leap for mankind. But in 1961, when Kennedy pledged to put a man on the moon, NASA had barely put a man into orbit. It was a pretty wide shock. Suddenly, we were leapfrogging from one man in Earth orbit to 3 men going 250,000 miles to the moon and back. NASA had less than 10 years to train a team of astronauts to overcome the unknown challenges of a mission to the far moon. Could a human being survive in this incredibly harsh environment? Nobody knew what the physical and psychological effects of spaceflight would be. Not only did the astronauts have to learn how to travel across the void of space, they needed to learn how to land on the moon and come back again. But for NASA, planting flags and footprints was not enough. It's really important for all astronauts that were going to walk on the lunar surface to do full mission simulations, learning how to collect lunar samples, how to run the experiments, how to take a good photograph. So practice, practice, and more practice was key. 3, 2, 1, liftoff. We have a liftoff. We're talking about an achievement which is right on the limit of what could be achieved even today. They had determination. They weren't going to give up when challenges emerged, and ultimately, they became the only human beings to have explored another world. This film tells the incredible story of how NASA trained America's best pilots to fly to the moon and take one giant leap for mankind. Incredible view, magnificent flight out here, music, applause, music. The Cold War gathers momentum, and the US Army continues to pioneer missile technology. But NASA's focus is on a different goal. Just 1 year after Sputnik goes into orbit, America's newly created space agency publicly announces their first space program, Project Mercury. The goal: to put a man into Earth orbit before the Soviets. Mercury was vital in order to demonstrate that Americans could go into space in the technology designed by American aerospace companies. We need to remember that more than 50 years ago, the global landscape was dominated by this geopolitical battle between 2 competing ideologies. We had the Soviet Union and communism. We had the United States and capitalism. And Mercury was the American program to push the Americans ahead to reach this milestone. The search for astronauts begins. NASA needs pilots capable of meeting the unknown challenges of manned spaceflight. So they turn to America's best. The military had done a lot of testing on high altitude, high risk stratospheric research. If you could gain the high ground, the stratosphere, you could gain an objective over your enemy. Pressure is going up. The test pilot would push an aircraft to the limit of its design capabilities, called the envelope. Nobody knew what the physical and psychological effects of spaceflight would be. There was no precedent for it. So they went for the max. Military personnel of supreme physical fitness. Wrecked though it seemed to be, both the aircraft and the pilots survived to continue with the program. So for the first selection of astronauts, what became the Mercury 7 group, they were exclusively drawn from the US test pilot community. Some from the Navy, some from the Air Force, from the Marines, but it was test pilots really being the prime focus for America's first class of astronaut candidates. The service records of 473 test pilots were selected for review. 110 met the basic qualifications. Music each must be a graduate of a Navy or Air Force test pilot school, 1,500 hours of flight time, qualified in jet aircraft, an engineering background, younger than 40 at the time of selection, and 5'11" or less. NASA whittles down 110 candidates to a final 32. Those 32 went through every imaginable medical test you can think of. They were prodded and tested to the extreme. Nobody really knew what these guys would encounter. Nobody knew if you could swallow food in space. They didn't know if the heart would operate normally, if blood could be pumped around. This is where pilots were very much a part of the physical exploration of what humans were capable of. They literally were guinea pigs. And so every conceivable test and every probing into every orifice, some you didn't know you even had to be imposed upon the astronaut selections before the first crews went into space. They were selected for their skills, their endurance, their physical condition, their mental state. They were the top. They were the cream of the cream. They were looking for people at the peak of their fitness and how they would respond physically to the marginal environments that manned spaceflight would provide them with. Music. On the 10th of April, 1959, NASA announces the names of the men chosen to fly America's first manned space program. Alan Shepard, Gus Grissom, John Glenn, Scott Carpenter, Wally Schirra, Gordon Cooper, and Deke Slayton become known as the Mercury 7. They instantly shoot to fame as national heroes set to conquer the new frontier of space. 6 solo manned space flights are scheduled, and the Mercury 7 are subject to a grueling training program. Following their selection, the men reported for their training. The academic program includes astronautics. The astronauts are being educated in the basic skills required to make scientific observations, in addition to a penetrating study of the physiology of orbital flight. Finally, in May 1961, NASA selects astronaut Alan Shepard to be America's first man in space. The countdown begins at Cape Canaveral, Florida, for one of man's greatest adventures, 7. Please clear the launching area. Liftoff. All right, liftoff and the clock has started. This is Freedom 7, reading you loud and clear. Fuel is go, 4G, 5.5, cabin oxygen, go. All systems are go. What a beautiful view. After Shepard's success, astronaut John Glenn becomes the first American to orbit the Earth. Reporters learn from the astronaut's information officer, if the most vital of all elements is ready, the man himself, John Glenn. All pre-start panel lights are correct. The ready light is on. Umbilical clear. Status check. Pressurization. Box tanking. You are go. Water systems go. Mercury capsule go. Roger. The clock is operating. We're underway. Godspeed, John Glenn. Little bumpy along about here. Roger. 0G. And I feel fine. Capsule is turning around. Oh, that view is tremendous. The achievements of Mercury prove that man could stay in space, survive, and come home. The missions were textbook. Everything went according to plan. But Mercury could only stay up for a few hours, really. They couldn't rendezvous and dock with another spacecraft. Spacewalking wasn't possible. It was just a man in a can. So, yes, we can do this. What can we do next? The 6 Mercury missions are a resounding success, pioneering procedures in orbital science and training. But America is already looking to the future. Inspired by Mercury's achievements, President Kennedy makes a bold declaration to the world. I believe that this nation should commit itself to achieving the goal before this decade is out of landing a man on the moon and returning him safely to the Earth. I think it's difficult now to fully appreciate the impact of President Kennedy's declaration of a national goal of getting an American on the moon and returning them before the decade is out. The space age was barely 4 years old. The Americans were behind the Soviet Union in what they're trying to achieve. And suddenly they're being told that within 10 years they've got to achieve what to many people seemed impossible. It was a pretty wide shock that suddenly we were leapfrogging from 1 man in Earth orbit for no more than a day and a half to 3 men going 250,000 miles on a 2-week mission to the moon and back. That was a pretty hefty shock. There were an awful lot of unknowns that had to be faced, that had to be planned for, and an awful lot of test flying, but in the environment of space, that had to be achieved. Music, what seemed to be pushing the engineering boundaries, very quickly became reality in this magical period of space exploration. I look at what was achieved between 1961 and 1970, and I still have this dreamlike sense of disbelief. Not that it happened, but the pace at which people were looking at the challenges and the way in which they were facing those challenges and moving rapidly on to the next step. If NASA is to meet Kennedy's ambitious target by end of the decade, they need a more advanced space program that will pave a flight path to the moon. The Apollo program is born, but with spaceflight in its infancy, a mission to the moon presents colossal challenges. Apart from designing and building the new Apollo mission hardware, NASA will require a new breed of astronaut to meet the unprecedented complexity of a lunar mission. Before taking even a single step on the moon's surface, these Apollo astronauts will need to fly with pinpoint precision over 250,000 miles through deep space, execute critical docking and navigation maneuvers, gently touch down at an unfamiliar and hostile landing site before returning safely to the Earth. Quite literally, one giant leap for NASA after just 6 solo Earth orbits. To bridge the technological void between Project Mercury and the Apollo program, NASA announces Project Gemini, a more advanced 2-man space program. 10 Gemini flights between 1965 and 1966 will provide the first real steps towards training Apollo astronauts for a moon mission. In the race to the moon, many people overlook Gemini, and yet without the 10 manned Gemini missions, we wouldn't have got to the moon by 1970. Every aspect of the methodology that was needed to get to the moon had to be rehearsed in low Earth orbit, and those challenges were considerable. Could a human being survive 2 weeks in this microgravity environment? How do you get 2 spacecraft to rendezvous and dock in orbit while they're traveling thousands of miles an hour? How do you rehearse the techniques that would enable a human being to survive outside their spacecraft in this incredibly harsh environment? Now, back in the days of Mercury, none of this had been rehearsed. So, in pretty short order, the Gemini spacecraft was designed. 16 Gemini astronauts are chosen for advanced training. Gus Grissom, Wally Schirra, and Gordon Cooper graduate from the Mercury project, while 13 newly selected astronauts will join the program. All military test pilots with advanced engineering degrees, with the exception of Neil Armstrong, a civilian test pilot already working for NASA. The 3 categories of piloting skills, engineering knowledge, and academic capabilities are all very important. But by the time we get to the Gemini program, you really began to major on engineering requirements and engineering skills, because you were going to be testing the very things that would underpin the Apollo program in an engineering fashion. The design and construction of the Gemini mission hardware is underway. The 2-man Gemini spacecraft will be more complex than the Mercury capsule. Using familiar aircraft instrumentation and advanced flight controls, Gemini astronauts will be able to manually fly this spacecraft in orbit. When the Gemini spacecraft was designed for 2 astronauts, it had an incredible amount of capability in terms of maneuverability, but also in terms of longevity. And that's where Gemini can really be regarded as the pilot spacecraft. And the astronauts at the time were intimately involved in designing the systems, as well as some of the future capabilities, not only of Apollo, but of Gemini as well. One of the main objectives of the Gemini project is to perfect the art of spacewalking. If a man is to walk on the surface of the moon, he must first leave the safety of his spacecraft. Gemini astronauts are the first to train for these specialized spacewalks known as EVAs, extravehicular activities. Learning to survive and work outside the capsule is NASA's top priority. Training for spacewalking is complicated. When you're on Earth in a gravity environment, initially the astronauts would go through training on what they call air-bearing floors, where they're on a platform that's on a shiny surface, basically a big table, and air is pumped underneath the platform and you glide across the table. Astronauts practice using the handheld maneuvering unit known as the zip gun, a device that allows an astronaut to fire pressurized oxygen from small jets to control his speed and direction in space. NASA also increases its zero-G training to simulate the weightlessness of space. The best way to practice in zero gravity is in what was known as the Vomit Comet, which was an aeroplane, a KC-135 with all the seats stripped out, and they would perform a parabolic curve. After a pull-up at 2½ G, a 35 degrees climb results in 15 seconds at 0 G. The maneuver ends with a 35 degrees dive and pull out at 10,500 feet. For between 20 and 30 seconds, you can effectively create the weightless condition. Music Every Gemini mission is designed to re-enter the Earth's atmosphere above the Pacific Ocean and have the capsule splash down within recovery distance of a US Navy aircraft carrier. Therefore, proficiency in water survival is essential. Water-based exercises include emergency evacuation of the capsule after splashdown and rehearsing helicopter recovery from the water's surface. Not only did the astronauts have to learn how to fly in space and operate all the equipment, they needed to learn what to do if things went wrong. In the event of an emergency re-entry to Earth, the Gemini capsule may land in a desert or remote jungle instead of the desired water landing. As an added safety precaution, NASA puts the astronauts through rigorous wilderness survival training, music remembering that these astronauts were also former test pilots and military men who had gone through survival training. This was just an application of a skill they already had. Learning to work as a team because your life depends on it is very similar to the military. Your team becomes your family, and if you're doing survival training in the middle of the desert, you need to rely on your colleague. So it is a matter of teamwork to ensure that you survive. Music. So yes, survival training is an integral part of astronaut training. On March 23rd, 1965, Mercury veteran Gus Grissom and John Young prepare to fly the first two-man Gemini mission. This is Gemini Control. The count T-minus 1 minute, T-minus 60 seconds and counting. Its primary objective to test fly the new fully maneuverable Gemini spacecraft. Music, we are going clear. 30 seconds speed. 109876543321. On the road now. Okay, go for Roger. Looks good from there. Roger. Okay, we're moving right along that horizon. Roger. Looks good. Molly Brown. During their 5-hour mission, they control thrusters to adjust the shape and altitude of their orbit. Gemini 3 is a success and begins the refinement of the flight techniques that will be vital to a lunar mission. In June 1965, astronauts Ed White and Jim McDivitt fly Gemini 4. They complete 66 Earth orbits in NASA's first multi-day mission. Astronaut Ed White completes America's first spacewalk. Okay, I'm out. Okay, I put a little roll in, took it right out. I'm under my own control. I feel like $1 million. Tethered to the spacecraft, he spacewalks for over 20 minutes. It's like a thermal gloss, Jim. It is. All right. Now, I've come above the spacecraft. Okay, I'm coming over. Okay, this is the greatest experience. It's just tremendous. Music Gemini 4's EVA showed that spacesuits work, that human beings can operate in the vacuum. The next challenge was to show whether or not an astronaut can do work. And this is where the difficulties came in. Gemini 9, Gemini 10, Gemini 11, Gemini 12. 4 missions to try to rehearse what's it going to be like to do physical tasks in space. And this environment is unforgiving. Gemini 9. What NASA learns is that doing a spacewalk is hard work. Eugene Cernan, who ended up being the last man on the moon, this was his first space flight, and he lost nearly a stone of weight. So something like 5 or 6 kilograms of sweat in his spacesuit, and barely managed to get back to the Gemini capsule in one piece. Gemini 10, Gemini 11. On those missions, as soon as the astronauts had to perform tasks, their spacesuits were overheating. They were realizing it required an incredible amount of muscular effort, and those challenges were really accumulating. If NASA can't solve these EVA challenges, they will never put a man on the moon. The final Gemini spacewalks rest on the shoulders of rookie astronaut Buzz Aldrin. An experienced scuba diver, Aldrin spearheads a new underwater training program known as neutral buoyancy. Music. In an inflated pressure suit, astronaut Edwin Aldrin, pilot for Gemini 12, is weighted with 60 pounds of lead. He is positioned at the prepared workstation by trained scuba divers. The neutral buoyancy tank is the best simulation you can get on Earth of microgravity, as we call it. In other words, essentially a weightless environment. You immerse the crew member and the things that they have to work with in a tank of water so that you can then adjust their buoyancy so that they float in one place and they can orient themselves very, very freely. Underwater simulation creates a condition of neutral buoyancy. It gives the pilot an effect quite similar to that of zero gravity. It's absolutely key to working out, in particular, how long things take and of course how easy things are in weightlessness. The jobs now performed underwater by pilot Aldrin are those which will be done on Gemini 12. A lot of the problems that had manifested themselves previously disappeared. Part of that is testimony to Buzz's capabilities, but a lot of it was also due to what was learned on those harrowing earlier spacewalks that had happened. If those test pilots involved hadn't undergone those travails that they did, then we wouldn't have reached the level of maturity that we reached by the time Gemini 12 flew in November 1966. NASA has one last chance to perform the perfect EVA. Thanks to neutral buoyancy training, Buzz Aldrin successfully spacewalks for more than 5 hours. Hey, congratulations. In December 1965, NASA launches astronauts Frank Borman and Jim Lovell on a 14-day mission to investigate the long-term effects of spaceflight on the human body. 11 days into the mission, Gemini 7 is joined in orbit by Gemini 6A. Gemini 7, are you able to see in the windows of 6 very easily? Roger, we're just flying a nose-to-nose, approximately 15 feet apart. Roger. Working together, the 4 astronauts perform the very first manned spacecraft rendezvous. How does it feel for the United States to be the new record holder? At last, huh? Roger. Congratulations. After 2 weeks in space, Borman and Lovell return victoriously to Earth, proving man can survive long-duration spaceflight. The demands of Project Gemini push each two-man crew to their physical and psychological limit. Gemini emerged in order to tick off the 3 essential boxes for a moon mission: long-duration flight of up to 14 days, extravehicular activity, EVA spacewalking, and finally, of course, there was rendezvous and docking, which was essential to come back to the mothership from the surface of the moon. And so without Gemini, we would have had to have put all those things into the Apollo program and been years behind. Of the final 5 Gemini missions, every single crew member went to the moon on Apollo. And it really shows that the people they were picking had the right stuff. They had determination. They weren't going to give up when challenges emerged. And ultimately they became... Their job is to conjure up every sort of nasty that can ever be thrown at a crew, and then some. Music. And to mercilessly put the crew through the most agonizing technical, emotional, and psychological stress they can possibly impose, and sit back and watch how they cope with it. This grade of gentleman is crucial to the whole training process. You want to get a hold of them and strangle them, but they are vital because they stress the crews beyond the limits they know that they're capable of. And it's that undiscovered area of an astronaut's potential that the SimSups group to find new ways of working out solutions. So they're important. SimSups are okay. To train astronauts how to fly and land on the lunar surface, the Lunar Landing Research Vehicle is developed. This training aircraft replicates how the lunar module will operate in the weaker gravity of the moon. Once they moved on to Apollo, a whole new phase of training needed to be accomplished. Now, of course, they needed to learn how to land on the moon. What they designed was called the Lunar Landing Research Vehicle. It's effectively a big engine with this lighter framework around it and the controls that emulate flying low at a reasonable descent rate, making sure that you've got sufficient resources to allow pretty realistic training and practice of the approach and landing. It was an incredibly faithful reproduction in control terms of the lunar excursion module, and therefore was a very, very important training resource. But these machines are unstable and difficult to fly, even for the best pilots America has to offer. 3 of the 5 built are destroyed in crashes. A couple of accidents occurred using that, including Neil Armstrong in 1968, where he had a fraction of a second to eject before the vehicle crashed in flames. So it's a highly dangerous vehicle, and certainly that training on the Lunar Landing Research Vehicle helped prepare the astronauts who flew the lunar module for landing on the moon. However, landing is not enough. Once down on the moon, astronauts will have to exit their spacecraft and walk on the lunar surface. Project Apollo was about getting to the moon and operating on the lunar surface. The difference on the lunar surface is that you got 1/6 of the gravity field strength as on Earth. So it was realized that somehow we need to be able to replicate 1/6 gravity conditions, and there were all sorts of ways that were used very successfully. One of the most dramatic ones was suspending from a rig where you lie horizontally and you walk along a wall suspended by a series of bungees. And the bungees provide you with just about the right restoring force against the wall to allow you to practice your various forms of walking and ambulation, the bunny hops and all this kind of stuff in a relatively realistic environment. You could successfully recreate lunar gravity. And this was done to look at the capabilities of astronauts to walk on the moon, but also to use tools on the moon and ultimately to use wheeled vehicles on the moon. All of it focused, though, on training the astronauts for the jobs they'd have to do in Apollo 321 Mark. We have you go for orbit here. Go for orbit. October 1968. NASA launches Apollo 7, the first manned mission of the program to rigorously flight test the new 3-man command module in Earth orbit. Beautiful. That was outstanding. Real fine. 109. We have ignition sequence start. All engines running. Liftoff. We have liftoff. The tower is clear. 2 months later, Apollo 8 conducts the first manned flight test of the Saturn V rocket. Apollo 8, Houston, you are going forward. Over. Apollo 8 is also the first mission to fly to the moon, where the crew conducts tests of the command module in lunar orbit. The mission successfully trials the navigation and guidance procedures vital for a moon landing. In the beginning, God created the heaven and the earth, and God said, "Let there be light," and there was light. March 1969, Apollo 9 performs the first tests of the lunar module. How does that sports car handle, Jim? Pretty nice. The crew successfully docked the command and lunar modules in Earth orbit for the first time. Apollo 9. Everybody's happy as a clam here. Looking good. Oh, this is very good. May 1969, Apollo 10 returns to the moon. Houston, we can tell the world that we have arrived. The mission runs a full rehearsal of the lunar landing. Flying just 8 miles above the surface. We is down among us. Charlie, Roger, you're weaving your way up the freeway. With all testing complete, the stage is now set to attempt a lunar landing. July 1969, Apollo 11 is go for launch. 5, 4, 3, 2, 1. Liftoff. We have a liftoff. Stand by for 1 Bravo. 1 Bravo. That's good. Real good. Forward, drifting to the right level. Okay. Engine stop. Houston, the Eagle has landed. We copy you down, Eagle. That's 1 small step for man, 1 giant leap for mankind. After almost a decade of dedication, NASA has won the race to the moon, and astronauts Neil Armstrong and Buzz Aldrin become the first of only 12 men to walk on the lunar surface. Apollo 11 was a great achievement for NASA because it demonstrated that the mission plan and the way in which the program had laid out all the various steps and the technologies and the hardware did actually work for real. So it was an engineering verification for the world at large. It opened a whole new chapter of exploring other worlds and of human beings being able to go from the Earth, which had been their home, the womb of humanity, to walk on the surface of another world was a very significant step for humanity at large. Although the space race is politically driven, the scientific benefits of Kennedy's goal are not lost on NASA. If astronauts can survey and sample the lunar surface, mankind's understanding of the moon, the Earth, and the solar system will be greatly enhanced. After the success of Apollo 11, NASA schedules 6 more landing missions. Each mission has its own scientific objectives, and NASA accelerates the scientific training for the astronaut corps. It's really important for all astronauts that were going to walk on the lunar surface, whether they had a test pilot background or a scientific background, to be trained in the art of recognizing different rocks. So they underwent a series of extensive training programs in places like the Grand Canyon. They even went to Iceland and Hawaii to look at lava fields, where they were trained by very eminent geologists on how to recognize different rocks, how to interpret the age relationships between different rocks. They also had a lot of classroom exercises where they looked at rocks under the microscope and in hand specimens. So it was a really valuable experience, and they were trained by some of the best geologists in the world to do that. When the astronauts got to the lunar surface, the first thing they did was to view the whole of the area and to report a local geological description. There's a relatively level plain, cratered, with a fairly large number of craters of the 5 to 50 foot variety, and literally thousands of little 1 and 2 foot craters around the area. The geological training also prepared them to collect the appropriate types of lunar samples that would present scientists with a wider range as possible about the local geology. It's obviously very cohesive because the bottom of the core is not smooth. It's very jaggedy and fragmental-like. Got it. Okay. What are you working on, Jack? I'm taking a pan. Very good. I'm coming right now. After the Apollo samples were returned to Earth, NASA and the USA decided to share some of that material with the rest of the world so that they could feel that they were part of this great exploration efforts. You know, we went to the moon as one mankind as opposed to one nation, so to speak. We'd like to share a piece of this rock with so many of the countries throughout the world. We hope that this will be a symbol of what our feelings are, what the feelings of the Apollo program are, and a symbol of mankind that we can live in peace and harmony in the future. To maximize the scientific potential of each mission, NASA develops the Apollo Lunar Surface Experiments Package, known as ALSEP. Okay, Bob, I've got my tools of the trade right here. These experiment packages were designed by scientists who wanted to address really key and interesting questions about the moon, such as what the lunar interior is like, if it has moonquakes, the interaction between the lunar surface and the surrounding space environment. These were small, lightweight science experiments that were left on the lunar surface by the astronauts to operate over a long period of time after they've returned to Earth. And they were trained to deploy them back on Earth prior to going to the moon. I'm going to go deploy an ALSEP. Well, we're off to see the wizard. ALSEP is the experiments that keep on giving. In fact, the lunar laser ranging stations are still studied at the present day, so ALSEP is an incredibly important part of the Apollo missions. Alongside their scientific and geological training, all Apollo astronauts receive exhaustive photographic instruction, music. The photography was clearly going to be very, very important on the mission, both documented as well as a record of the mission for people back on Earth. Photo documentation for geological purposes, for sample analysis, photographing in situ a rock before you moved it. Then after you lift the sample, you have to photograph and document the place it's come from. So you get a reference. You know, you didn't expect to see anything crawl out from under that rock, but if there was, you wanted a picture of it. Context is everything in geology. So when we have a hand specimen sample, we want to know the bigger picture. On the moon, this is really important because all the rocks that were collected, they've been thrown to their present locations by impactors or other types of complicated processes. So by taking a photograph of the sample on the lunar surface, we could understand where that rock originated from and what that tells us about the local geology. When crews visit geological sites on Earth, they also practice with the body-mounted cameras that we use on the moon. The body-mounted cameras were very difficult to use, mainly because of the constraints of the suit. The principal problem is sighting the camera. You have a helmet on, and the helmet is effectively joined to the suit, more or less at your neck. So you can move your head, but the helmet doesn't move. You can't even look down into the viewfinder. So it was really about learning, by dead reckoning, how to position the camera in front of them, and it took a long time. As the missions progressed, it got a lot more sophisticated, and the training that was required for that was quite considerable as well. Some of the crew did it better than others, and some were more natural photographers than others. But there was a lot of training that went on in that area, but with varied results. Some of the photographs from Apollo that look back at the Earth were some of the best things that happened on the space program. The legacy created the environment movement. The pale blue dot floating in space turned people's imagination, saying, wow, we need to look after this planet. I think we've seen as much in 10 days as most people see in 10 lifetimes. NASA's quest for more scientific exploration results in what were known as the J-class missions. The J missions brought extreme demands in that suddenly there was a very wide variety of tasks that the crew had to do, and that was grafted onto an already demanding training program. It's interesting how we came to have more science within these manned missions, because initially NASA felt that these were largely engineering ventures and there was pressure from the outside. There was a National Academy of Sciences in America that was constantly banging on the door of NASA. And so NASA, and it has to be said reluctantly, began to recruit scientist astronauts whose primary skills were not in piloting or engineering. And it started with Harrison Schmitt on Apollo 17. And in fact, he was put in and a crew member taken out in order that NASA could say, there you go, we flew a scientist to the moon. And in fact, he was instrumental in discovering the location of some volcanic debris, the famous orange soil. There is orange soil. Well, don't move it till I see it. It's all over. Hey, it is. I can see it from here. It's orange. Fantastic. Sports fans. Jack, that is really orange. Having a geologist there really helped for serendipitous discoveries and recognizing rock types that maybe some of the other astronauts wouldn't be trained to recognize. Schmitt certainly has left a legacy for the training of scientific astronauts. And as NASA's planning to go back to the moon and to go to asteroids and Mars in the future, I have no doubt that geologists will be part of that exciting experience so that we can maximize the scientific return from these landed exploration missions. In preparation for the last 3 Apollo missions, NASA trains its crews to operate a small 2-man exploration buggy known as the Lunar Rover. Man, this is a fun ride. My gosh, this is really something, man. You are really bouncing, Yahoo. The problems with the early missions, Apollo 11, 12, what was planned to be 13 and ultimately done on Apollo 14, was a pretty limited geological footprint of area that you could explore. Basically, the astronauts were limited by how far they can walk from the lunar module and come back, and that means they're exploring a geologically less diverse area than they could. And so it was realized that having some type of roving vehicle on which the astronauts could traverse a lunar landscape at much higher speeds than they could walk meant that the science yield could be higher. Okay, doing 10 clicks, outstanding. This is really some machine. And as he turns, he skids, just like on snow. It's just like driving on snow. You, by golly, see, I know all about that. I know you do. But us Florida boys don't know when to stop. When you look at the amount of lunar surface that was covered, we're talking 15 to 20 miles by the time Apollo 17 had flown. The fieldwork return, the amount of science that's come out, the amount of samples that they took, the amount of documentation that they did was absolutely first rate. And in fact, it just goes to show that Project Apollo proved there is nothing that will compare to having a trained observer, be it on the moon and ultimately be it on Mars. Music. 3, 2, 1, ignition, on our way. Houston, take your final look at the Valley of Taurus Littrow. As Apollo 17 lifts off the moon's surface on December 14th, 1972, it not only signified the end of the Apollo program, but the greatest chapter in the history of human exploration. When President Kennedy pledged to put a man on the moon, NASA had barely put a man into orbit. Yet, little more than a decade later, NASA had successfully crossed the vast technological gap between Project Mercury and Apollo and the vast ocean of space between the Earth and the moon. The training in the Apollo program was the pivotal key to being able to move forward to the shuttle program, which is why NASA is so proud to keep as its core all of those lessons over the last 50 years that it has learned. That is the bedrock. It is the structure that is viewed as a template for everything that stems from it. I think the greatest legacy is that there are 2 generations of engineers who draw inspiration from what was achieved not just by the astronauts but by the engineers. We're talking about an achievement which is clearly right on the limit of what could be achieved even today. And it forms an ideal which engineers still strive for. It's a benchmark of achievement. Today we look back and marvel at NASA's technological and scientific achievements of the 1960s. But we should never forget or underestimate the bravery, skill and dedication of the Apollo astronaut corps. Men with sharp intellect and sharper flying skills who put their lives on the line to answer Kennedy's call. I think many people have contributed to this pinnacle we've reached. Some have contributed more than others, and we know of 14 individuals who contributed all they had. And because of that, why we left a small memorial on the moon in a small, subtle crater, there's a simple plaque with 14 names. And those are the names, in alphabetical order, of all the astronauts and cosmonauts who have died in the pursuit of exploration of space. Near it is a small figure representing a fallen astronaut. Looking at the Apollo group of astronauts, the stereotype is that it was the right stuff and, yeah, strap it on and go, and to hell with the consequences. But actually, when you look at the very, very broad range of personalities, the one thing they all had in common, and I think this continues to today's astronauts, is an absolute dedication to their task. A real commitment to teamwork and a realization that what they were doing was just at the sharp end of a pyramid built on the achievements of thousands of others. And I think the legacy of the Apollo experience has provided the perfect template for future crews. Between 1968 and 1972, 24 men flew to the moon and 12 walked upon its surface. When Neil Armstrong took those first historic steps, not only did it represent mankind's ability to overcome any challenge, but it symbolized the courage and determination of a few extraordinary men who were made of the right stuff. Music. Heat. Music. Music.